Astronomers were excited to discover the interstellar object last year. It was named Oumuamua.
What would happen if an uninvited guest returned from interstellar space? As it turns out, we don't have to wonder anymore. This might soon become a reality, thanks to the unparalleled power of the James Webb Space Telescope. We now have a remarkable opportunity to once again observe a cosmic mystery. The last time Oumuamua was here, it baffled scientists and enthusiasts alike. Now it's back, and there's something even more bizarre about its recent appearance. But what do we know about Oumuamua, and why has its return had the entire scientific community shaking in their laboratories? Hold on to your seats because we might be looking into something extremely dark, emerging from the fathomless void of interstellar space. Oumuamua wasn't merely a celestial blip or a routine space rock. This was no ordinary visitor. This was our inaugural interloper from another star system, an ambassador from the cosmos beyond our own. Picture this, an elongated cigar-like entity darting through space, its speed and trajectory defying our understanding of how objects should behave under our sun's gravitational influence. Instead of the familiar elliptical orbits we see of asteroids and comets, Oumuamua, with uncanny audacity, chose a hyperbolic path, unequivocally hinting at its otherworldly origin. The deeper our telescopes peered, the more Oumuamua eluded comprehension. That reddish tint, a hallmark of objects bathed and bombarded by cosmic rays for eons. Yet an essential component was conspicuously absent from this interstellar traveler, a halo or tail typically seen billowing from comets as they flirt with our sun's warmth. This was more than just an astronomical anomaly. It was a confounding puzzle making even the most astute experts in the field scratch their heads in bewilderment. But Oumuamua's surprises didn't stop there. Its rapid gyration, coupled with an inexplicable acceleration, especially as it journeyed away from the sun, left the crème de la crème of our scientific community in a state of perplexity. The urgency to understand this acceleration was palpable. Newton's laws, the bedrock of our understanding of motion, fell short. What was causing Oumuamua to pick up speed when everything we knew whispered it should have been decelerating? The hypotheses flew thick and fast. Some opined it could be the result of outgassing, a phenomenon observed in comets. Yet no visible traces of such processes adorned Oumuamua. In the echoing void of hard evidence, audacious postulations began to surface. Could it be possible, just maybe, that Oumuamua was not a product of nature at all? Might it be a crafted object, an interstellar probe designed by an alien civilization to scrutinize our corner of the Milky Way? Professor Avi Loeb, a luminary from Harvard, stepped into the fray, postulating that Oumuamua might be a light sail probe sailing through the cosmic sea, propelled by radiation. While many eyebrows were raised in skepticism, Loeb's proposition added an electric charge to the discourse. However, as swiftly as it had appeared, Oumuamua retreated from our observational grasp, leaving a trail of enigmas in its wake. Its fleeting rendezvous with our solar system has birthed more riddles than revelations. Whether a naturally formed cosmic voyager or an emissary from a far-off civilization, its true nature remains cloaked in mystery. What stands unchallenged is this: Oumuamua's unexpected sojourn has jolted our astronomical paradigms, compelling us to gaze deeper into the vast cryptic expanse of our universe, urgently seeking answers. Now, before we delve into what the latest discoveries regarding Oumuamua say about our understanding of it and the entire cosmos, we need to understand how we made this discovery to begin with. Imagine a portal that can penetrate through the veils of time and space, offering us a glimpse of the cosmos like never before. The James Webb Space Telescope is just the device for that purpose. An engineering marvel, it has been hailed as the most advanced, meticulously designed to decipher the mysteries that have eluded scientists for generations. One of its crowning features is the ability to detect faint heat signatures from celestial bodies, a feature that promises to redefine our understanding of planetary atmospheres, including those of exoplanets. Now, let's delve deeper into its cosmic purpose. The universe, vast and infinite, is teeming with phenomena that we've merely scratched the surface of. The James Webb Space Telescope is on a profound mission to track and study these wonders in a depth and detail that was once thought impossible. It promises answers to questions that have haunted humanity since we first looked up at the night sky. Where do we come from? Are we alone in the universe? The James Webb Space Telescope is our sentinel, monitoring cosmic events and sending back data that could unlock these secrets. Supernova, black holes, and enigmatic dark matter are just some of the phenomena that this telescope will scrutinize. Among its myriad of breakthroughs, the telescope's infrared prowess has unlocked never-before-seen regions of star-forming nebulae, revealing a vibrant nursery of stars. Some of these stars challenge our existing knowledge of stellar formation. These newly discovered protostars, birthed in conditions vastly different from those theorized, urge scientists to re-evaluate our foundational concepts. The James Webb Space Telescope has also identified the faint signatures of exoplanets residing in the habitable zones of their parent stars, a leap in our quest for potential life outside our solar system. Some of these exoplanets exhibit atmospheric compositions suggestive of potential biological processes, hinting that life might be more prevalent than previously assumed. Most urgently, however, has been the telescope's peering into the ancient universe. It has captured light from galaxies so distant and thus so young that they existed a mere few 100 million years after the Big Bang. These images, hazy windows into the universe's infancy, highlight the formation and evolution of primordial galaxies. By understanding these ancient cosmic entities, we're essentially decoding the origin stories of galaxies like our own Milky Way. To say that the James Webb Space Telescope's discoveries are groundbreaking is an understatement. They are earth-shattering, paradigm-shifting revelations, each beckoning us with a sense of urgency as we stand on the precipice of a new era in space exploration. The urgency cannot be understated. The James Webb Space Telescope isn't just a telescope. It's a beacon guiding us through the cosmic dark and revealing the universe's enigmas. It's a call to humanity, urging us to look beyond our world, to push the boundaries of our understanding, and to embrace the boundless wonders that await. With the James Webb Space Telescope, we're not just observers. We're active participants in a cosmic odyssey that promises to reshape our very understanding of existence. And so it has. In a breathtaking revelation, the James Webb Space Telescope has once again detected Oumuamua, the elusive interstellar object that puzzled astronomers during its brief stint near Earth years ago. With its unmatched infrared capabilities, the telescope pierced the vast cosmic dark, capturing intricate details of Oumuamua that previously eluded our best instruments. The trajectory details are nothing short of astonishing. Contrary to its initial fleeting visit, Oumuamua now courses through our solar system in a provocative arc, challenging the conventions of astrophysics. While other comets and rocks floating in the universe are influenced by the gravitational influences around them, Oumuamua seems to be having its own trajectory, untouched by any foreign influence. Its current position, a mere stone's throw from Mars, adds layers of urgency to its mysterious presence. Why has it returned, and what does its altered path signify? The world watches with bated breath as scientists scramble for answers. Oumuamua's return is not just a momentary cosmic event. It's a clarion call for humanity to peer deeper into the enigmas of our universe, and the answers we seek might just be lurking in the shadows of this reinvigorated celestial wanderer. In the vastness of space, it is rare for celestial objects to capture our collective attention quite like Oumuamua has. Its name hails from Hawaiian origins and translates to scout or messenger from afar, and it seems Oumuamua is living up to its moniker once again. But this time, its return is veiled in an aura of greater enigma and urgency. The first time we encountered Oumuamua, it was a fleeting visit, a mere blip on our cosmic radars. But even then, its elongated cigar-shaped structure and rapid rotation intrigued scientists and stargazers alike. Now, as it embarks on its mysterious return voyage, Oumuamua's behavior is even more perplexing. Its trajectory doesn't simply adhere to the gravitational dance that most comets and asteroids engage in. Instead, it seems to be moving in patterns that defy our current understanding of celestial mechanics. What makes this return truly special and profoundly mysterious are the new observations instruments have detected sporadic bursts of energy emanating from it. Akin to a beacon flashing in the abyss of space, this is not a behavior typical of any known natural space object. Additionally, its surface properties appear to have undergone some alteration, hinting at external influences or perhaps internal processes that remain unfathomable to us. The urgency of this matter cannot be overstated. What is Oumuamua trying to tell us? Is it a mere space rock with unique properties, or is there more to its tale than meets the eye? As it cruises through our solar system, its enigmatic presence beckons the brightest minds to decipher its secrets. The message from the cosmos is clear. Oumuamua's return is not just a celestial event. It's an urgent cosmic mystery that demands our undivided attention. In the vast, mysterious cosmos that surrounds our tiny blue planet, few objects have sparked as much intrigue, controversy, and speculation as Oumuamua. First observed in 2017, This enigmatic interstellar visitor defied categorization and sent the scientific community into a frenzy of debate and analysis. And now, with its reappearance, the enigma intensifies, and we are once again forced to grapple with a maddening question. What exactly is Oumuamua? When Oumuamua was initially spotted, its elongated shape, high-speed trajectory, and non-gravitational acceleration raised eyebrows among astronomers. Natural explanations were put forth in an attempt to shed light on this cosmic oddity. Solar radiation pressure emerged as a lead contender in the slew of explanations. Picture this. On our blue planet, the wind, gentle or fierce, propels sailboats across vast oceans. The force, though invisible, is palpable and powerful. Could the same principle be at play in the dark abyss of space? The sun, in its raging glory, emits a barrage of particles. If these particles collided with a flat, thin object in space, could they not push it, making it accelerate? Such a phenomenon, although absent in the vast majority of celestial bodies we've studied, held the promise of demystifying Oumuamua's arcane trajectory. Yet, the cosmos is a treasure trove of possibilities, and where one theory emerges, others are sure to follow. Enter the idea of comet-like outgassing. Our understanding of comets is quite clear. As they dance closer to the sun, they discharge gases in a spectacular display, almost as if they're exhaling their essence. This outpouring of gas can function similarly to rocket propellants on spacecraft of the force. The momentum, the push, it could be enough to propel Oumuamua in its mysterious path. But here's where the plot thickens and the intrigue deepens. Comets, in their celestial flamboyance, display tails or comas, shining markers of their paths. But Oumuamua, ever the enigma, showed no such feature. There was no telltale tail, no radiant coma. It was as if it was a comet, but also not. The very absence of this comet signature cast a shadow of doubt on the outgassing theory. Was this another cosmic curveball, or was there something we were missing? While these natural explanations offer some potential answers, they also come with a series of questions. Why didn't we observe the typical characteristics of a comet? Why was its shape so peculiarly elongated, unlike anything we've ever seen? This is where speculation ventures into the territory of the extraordinary. The behavior and features of Oumuamua have led some to believe that it could be more than just a peculiar rock hurtling through space. Could it be artificially made? The sheer irregularity of its behavior and characteristics prompted some scientists and enthusiasts to speculate that Oumuamua might be an artificial probe sent from a distant civilization to observe our solar system. Its elongated shape might serve a specific function or purpose, perhaps as a sort of antenna or probe. Its acceleration, which doesn't align with known natural phenomena, might indicate some form of intelligent control or propulsion system. Considering this theory is exciting, but it's crucial to be cautious. To believe in the idea that Oumuamua has an extraterrestrial origin, we need solid proof. It's not enough for it to be interesting. There has to be real evidence. However, the mere existence of this theory tells us something intriguing about Oumuamua. It's a puzzle we're still figuring out. Scientists don't fully comprehend its nature, which is why they're exploring various possibilities, even ones as far-fetched as aliens. Yet until there's concrete support, we can't jump to conclusions. Oumuamua's enigmatic nature alone is enough to captivate our curiosity. It's like a cryptic message from outer space, and deciphering it is a journey that showcases the limits of our current knowledge. With Oumuamua's return, we are presented with a golden opportunity to gather more data and potentially find answers. However, early observations suggest that the mystery has only deepened. Comparing its current behavior and trajectory with data from 2017, Oumuamua seems to be exhibiting even more unpredictable patterns. Its speed, direction, and even its physical properties seem to be slightly different than during its last pass. These changes further complicate the already challenging task of understanding its nature. Moreover, scientists' prevailing theories based on combined data lean more towards the unknown than before. The new observations neither solidly confirm nor refute any of the prevailing theories, be they natural or extraterrestrial. Instead, they highlight the need for more advanced monitoring equipment, more time, and perhaps even an ambitious mission to intercept or closely observe Oumuamua. Here's where speculation becomes both exhilarating and daunting. What if Oumuamua is not an anomaly? Consider for a moment that our solar system is merely one tiny point in the vast cosmic tapestry. The universe, with its billions of galaxies, each teeming with countless stars and planets, might be bustling with countless Oumuamua-like objects darting between the stars, carrying with them stories from distant corners of the cosmos. If Oumuamua's return teaches us anything, It's that the universe is more dynamic and unpredictable than we ever imagined. As our detection capabilities improve, it's entirely conceivable that the skies might soon be filled with alerts of other such interstellar travelers. Even before the dust of Oumuamua's last visit settled, astronomers globally had their telescopes trained on its predicted path, eager for its return. These aren't just casual glances. High-powered telescopes and satellite systems have been tweaked and recalibrated with one primary objective: continuous and detailed monitoring of Oumuamua. The mystery surrounding its peculiarly elongated shape, unexpected acceleration, and ambiguous origin has only heightened the urgency. In a bid to extract as much knowledge as possible from this object, there's a deluge of potential missions on the horizon. Rumors are swirling of specialized probes being designed, equipped with advanced instruments capable of closely observing and perhaps even landing on Oumuamua. While these remain in the realm of possibility, one thing is clear: scientists aren't letting this opportunity slip by. Think of these potential missions as deep space detectives, zooming in on an object that might hold clues to the vast universe's workings. However, probes and direct studies aren't the only things brewing. Given the whirlwind of excitement Oumuamua has generated, scientific consortiums are coming together, combining data, research methodologies, and intellectual resources. This coalition seeks to construct the most detailed profile of Oumuamua we've seen yet, from its chemical composition to its potential as a harbinger of extraterrestrial civilizations. No theory is off the table. The race is on, and the next chapter of Oumuamua's story promises revelations that could reshape our understanding of the universe. So, what should you, the eager observer, expect in the coming months? First and foremost, prepare for a media blitz. Every minor discovery or hypothesis related to Oumuamua is going to be under the microscope, scrutinized and broadcast with feverish excitement. Websites, journals, and news channels will be bustling with updates, each more thrilling than the last. Speculations will range from the scientifically grounded to the wildly imaginative, keeping viewers on the edge of their seats. But beyond the media frenzy, expect significant breakthroughs. As more telescopes are trained on Oumuamua and as more missions are launched, new data will pour in. This data, combined with the power of modern analytics, is bound to shed light on some of the long-standing questions surrounding this object. Was its acceleration due to outgassing, as some posit, or does it hint at a more exotic origin? These questions and more will soon find answers. Thanks for joining us. Don't skip the video displayed on your screen. It's mind-blowing.